everyone. Good afternoon from the UK or good morning, depending on where you are in the world. We shall get started. So my name's Ellis McCoy. I'm a business development manager here at Raytech, looking after our security and transport divisions. Today's webinar is looking at lighting for ANPR and barrier control. It should take approximately 30 to 40 minutes, and then we'll have some time at the end for questions. Regarding questions and some housekeeping, so everyone will remain muted for the duration of the webinar. However, I would urge you to write any questions that you might have during the call in the questions box. Hopefully you can navigate the GoToWebinar interface, and we will answer each one towards the end of the slides. My colleague John Patterson, who's our Special Projects Manager, should be joining, and he'll be able to lend some additional expertise to answer your questions. Further to this webinar will be recorded. We'll send out the slides and recording after, so anybody that was signed up and hasn't been able to attend will receive a copy. But for those of you who are attending, you're very welcome to send this on to anyone within your organization that might find it of interest. So with that, we shall get stuck in. So agenda, we'll do a quick introduction just to lay the ground and make sure we're all on the same page. Look at some standard applications where we see these kinds of solutions fitting in, and then look at some specific examples of case studies that we at Raytech have worked on more recently. Then we'll get into the meat of the presentation, so looking at the challenges, so what's stopping you from picking up good quality images, and then solutions, best practices on how to combat those. Finally concluding with a short summary and a Q&A. So, introduction. So what is ANPR? It's probably an obvious question to some of those on the call, but just so we're kind of all on the same page, it's a conversation regarding ANPR, automatic number plate recognition, or LPR, license plate recognition, as it's more generally used, or the term generally more used in North America. However, we're also going to be talking, or this will also incorporate discussion over OCR, which follows all the same principles, but at least in our consideration falls under a different subtext. So barrier control has shifted dramatically from manual systems to fully automated setups, with ANPR now playing a crucial role. ANPR allows vehicles to be identified and access granted without stopping or requiring interaction. Obviously ideal for parking lots, gated communities, secure facilities, etc. This is especially valuable in environments needing fast, potentially touch-free entry and exit. However, none of this works reliably without good lighting. Poor lighting means poor image quality, which means poor recognition, and that's why lighting is not optional, it's foundational. So some of the more common applications that we've worked on at least include ticketless parking, which is definitely something that's grown in popularity, probably the wrong word, but becoming a more common occurrence over time. Commercial and logistics sites, and this kind of for us includes sort of more OCR related activities, which might be looking at shipping containers or the characters on the side of trucks, for example. As mentioned, residential gated access, airports, transport hubs, border control, law enforcement, which again is a very large part of what we've been doing, especially over in Central and Eastern Europe. And each of these scenarios has different lighting requirements, and that's the main thing. And we'll touch on this repeatedly over the course of the presentation. But depending on the distance, the vehicle speed, ambient light levels, different solutions are required for each circumstance and need to be thought about independently, and testing is required in a lot of cases. So let's look at some real world examples. This first one is Zurich Airport. So here security, reliability, high performance are essentially critical. Vehicles are moving in and out during all day and light conditions. And in this circumstance, Raytec provided infrared solutions that ensured consistent ANPR performance, as mentioned, any time of the day, or indeed any weather that was currently occurring. This kind of controlled lighting ensures that the ANPR system captures sharp and clear images at all times. Now, kind of wanted to start with this one because it's a, dare I say, like a perfect example. With this specific setup, it's perhaps the easiest to achieve good results. If we're looking specifically at this image, it's undercover. It's close to the entrance where the vehicles are going to drive through the gate. The cars are going to be driving slowly because they obviously have to stop at the gate. It's a narrow field of view. We're able to install the lighting precisely where the camera location is. So it's kind of the best of all examples. This is, bread and butter sort of thing. Not all applications are going to be like this, and there's certainly tips and tricks where you can mount the lighting in different locations. It would have to be on the same axis for it to work with retro reflective plates. But yeah, there's lots of different tricks that you can employ to get around more tricky environments. At this particular site, we're using our Vario 2 low voltage illuminators. So these come in a range of different sizes, anything from 10 watts up to 100 watts, with different wavelengths, though we'll touch on that a bit later. In terms of distance, we would consider these to provide 78 up to 500 meters at a narrow 10-degree spotlight. Now, it should be pointed out that these distances are based on what we would perceive as security camera, CCTV type applications with something in the realm of a 1/50 shutter speed. Now, casting our mind back to the Zurich application, there cars are going to be slowly moving in. And so it's unlikely that the shutter speed needs to be much higher than that, albeit probably will be based on the application type. And in applications where vehicles are faster moving, you would then therefore need a faster shutter speed, and then we would have to calculate those max distances differently, but we can touch on that a bit later. The next case study is little car parks, and this is maybe a little bit closer to home because we've got one such installation very close to us. In a retail environment like this, priorities shift obviously away from it being more security related to it being more speed and customer convenience being key factors when when setting this up. So obviously trying to create as little friction between a customer getting parked, getting into the shop and spending their money. The tricky part of these installations was the angle of entrance. So in this example, the company was ANPR, who was our partner doing the installation work. And they were, in some cases, they were installing 30, 35 degrees away from, or at a 30 to 35 degree angle away from the entrance road, and therefore the plates of the cars that are entering. What's commonly agreed is that 25 to 35 degrees is kind of the max angle when working with retroreflective plates for the light to bounce back into your camera. And again, we've got slides kind of talking around this a little bit more in depth. On that point, of course, non-retro plates, if you're working in a part of the world, state, country where you have non-retroreflective plates, those angles don't necessarily apply. However, then it's more pressure on your analytics to figure out the characters when warped at very tight angles. So it's something to consider. This application was using our Vario 2 Lighthouse kit, which combines lighting, housing, mounting, all built into a single product. Athena in this case, obviously quite well, they enjoyed using it because it allowed them to set up the cameras, lighting and everything from the office. And then installation on site was a lot quicker a process with a lot less clutter. And the lighting on this is fine-tuned to provide enough light in order to accurately capture under all conditions, even in somewhere like Lidl, which can be very busy and often chaotic at times. Another example, so shopping centres and malls, so somewhat similar to Lidl, but again, these often involve a mix of ambient lighting, so you've got general area lighting on scene, but also areas of darkness. You've got indoor and outdoor transitions, and of course, high vehicle volume. In this example in Japan, it was a shopping center car park. They applied charges after 3 hours of the vehicle being parked. So it was important for their the financial side of the car park operating properly in order to capture all the plates and make sure that it was all going through perfectly well. The image on the right there was a similar case where they used our Vario 2 i4s, and this was for Aeon Mall in Kyoto. This was somewhat different, but they had barriers, and their motivating factor was to ensure flow of traffic and aid in parking management. So very similar applications, these being a lot closer range. So again, they didn't need necessarily as powerful a product to achieve the desired results. So let's dive into challenges, which I think is probably the most important part of this session. These are, well, what we're going to talk about are kind of the issues that can be the difference between getting a highly accurate number plate capture or complete failure. And if we don't get lighting and setup right, even the best cameras and software can't help. So let's walk through these key problem areas. So the first one is glare and also poor lighting conditions demanding weather. So glare could be from the vehicle headlights, particularly in low light conditions, or from wet surfaces like tarmac during the rain. Could be from general area lighting, or again, the car headlights bouncing off those surfaces. These sources of uncontrolled light can overpower perhaps like inbuilt infrared, or if you're using general area lighting on scene, create bright spots and reflection bands that obscure the number plates entirely. Glare often comes down to angle and power control. That's why pulse lighting in some cases, careful beam shaping and directional placement can be so critical. The next issue is the plates themselves. Not all license plates are standardized globally, and not all license plates reflect light in the same way. So this comes under large geographical differences. So for example, UK, we have like the EU standard plates. It's very consistent across the country. Europe, for example, again, fairly consistent. However, you do have Belgium, which uses red lettering on a white background of the plate. So again, very different. However, if you go to the States, then of course you cross state lines, you get different plates. Even within states, you can get different plates. Canada is exactly the same, and Middle East as well. You can get vastly different plates as you go country to country. If a plate is curved, dirty, made of a different material, like some temporary dealer plates can be, then the light scatters unpredictably. This makes it incredibly difficult for cameras to capture a sharp and readable image. And certainly we've seen major reliability issues in systems that weren't necessarily designed with these variables in mind. An example of that might be, for example, ANPR systems set up in the Netherlands, where they are expecting standardized EU plates, but then get Belgian plates coming through, which would be unreadable with a standard infrared system. So just to dig into this further, most plates are made of reflective material. Those would be like the EU plates, as we previously mentioned, either specific plastics or paints, but many are made of plastic and some metal ones as well. The size of the plate can be important. In some states, they only allow a single plate to be fitted, which can also be a challenge. The coloring and lettering, or the color of the lettering, may affect the choice of lighting. So mainly around which wavelength you might want to use. So for example, those Belgian plates with red lettering on a white background, the red lettering can reflect infrared well enough so that there isn't enough contrast for the analytics to accurately read. So essentially the red lettering is bouncing almost as much light back as the white is, and so it almost looks like a blank plate well, to some degree, versus black lettering, which would absorb some of that lighting, and therefore that would create the contrast versus the reflective background. You can also have issues with the fonts, and I know this is a particular point for the analytics companies, so Vaxtor, who we've worked with more recently. They have to design their analytics and sort of train their models specifically so that they can pick up different characters, different width of characters, etc. Though some countries like the Netherlands have adjusted some of the letters on their plates to improve recognition. So if you look at the bottom right there, you can see that the R has a little notch cut out of the top of the letter, and this is specifically so that that can be better differentiated versus other letters, the B, for example. Albeit to the human eye, when we look at it, it looks very similar. If you start adding dirt and grime to the plate, then that can have an impact in the overall readability, and they've been designed in order to avoid that. So why are plates so variable? And we can talk a little bit about physics, about the way that light is reflected from a plate. So there are three typical sorts of reflection when light hits an object and is reflected. The most common is diffuse reflection, or diffuse even, when the object reflects light in all directions to varying degrees. And this is the most common type of reflection, and the vast majority of objects reflect light in this way. The least common is specular reflection, and this is when an object reflects light without changing its direction of travel, so it bounces off the object and continues to travel away from the source, and in this case away from the camera too. So if you can imagine, there's no light therefore going to be reflected back into the camera to generate an image. A typical example of specular reflection is something like a mirror. Some very shiny metal objects, very calm water, hence why you can get those lovely Instagram-worthy shots of reflections of mountains and such. Theoretically, the retroreflective license plates could also become specular too if you exceed that generally agreed maximum of 25 to 35 degrees angle away from the plate itself. More common than specular, though, is the man-made invention, and that's retroreflective. This means that the light returns in the same direction that it strikes the object, which means most of the light is usable by the camera. And effectively, that's why plates appear to be so reflective when light is shone on them. They are only reflective if you stand in line with the light that is illuminating them. It's also the reason that in normal video surveillance applications, when using light and a camera, the plate can often appear washed out, whited out, or overexposed, over-illuminated, because so much of the light is reflected back to the camera, whilst other objects in the scene are diffuse reflectors. Only a small percentage of the light is reflected back into the camera and could be correctly illuminated. This again is why camera setup is super important, and we've had actually just an example this week where we had a customer complaining that the lights weren't working, and it turned out that actually with some clever setup of the camera, I say clever, we adjusted the shutter speed primarily, turned off the integrated infrared. We were reducing the amount of bounce back from the plate, so it reduced the overall darkness of the image, but actually the plate was so much more readable because of it, and that's ultimately what they needed the system to achieve. So capturing the plate, what do you need? Obviously, you need a good quality camera. You need a good quality lens. Filters are important. So for example, if you are aiming to capture it in monochrome through the day and night, then you maybe want a bandpass filter or a cut filter. If you are wanting to look through car windscreens, for example, then having a polarizing filter is something that we've done a lot of testing with over time to see how that can impact your images. And we will touch on this briefly later on in the slides. And finally, you need enough light in order to correctly capture the images in exactly the way that you need it. Our chairman coined the phrase or used the phrase garbage in, garbage out. Essentially, if your camera is capturing poor quality images, then even with the best software, it won't be able to fix it. So proper specification of hardware and a good quality analytic is super important to get exactly the results that you need. So to give you an example to round off this section, our partner in North America, Watchtower, started noticing readability issues at nighttime. They ensured the system functionality and they did a load of testing, retuning the cameras, but they're still missing plates regularly. Later, they realized that in the last year or so, the states of Tennessee and Indiana were changing their license plate design, specifically the color and texture. And this change caused issues with the camera's ability to properly identify vehicles with the ANPR technology as they entered and exited the communities. Previous designs of these license plates were aluminium with a retroreflective material that was made using tiny glass beads that reflect light back towards its source, stamped with raised letters, and that was what created the contrast that allowed you to pick up the characters. But they changed this to a completely flat polymer/plastic plate with a blue background and white letters. So this is essentially what they were seeing on the left there. And in this case, Watchtower worked with our North American team to find a suitable solution. Ultimately, they decided that they needed more power in order to create that contrast and pick up the plates, and they went for our IPPE i8, so our network illuminators, in order to do this. And then, as you can see on the image on the right there, all the plates are very readable, but also actually they were starting to cut out glare from the headlights as well. So I think the image overall is a better quality image. You can see the badge of the car, for example. So onto solutions. From Raytec, you've got three main variants of products. So you've got white light, which provides color images. Obviously, white light is visible light, so completely within the human spectrum of visibility. We generally see white light being used for applications that require it. We'll touch on in a second. The downside of white light, however, is glare and driver distraction. So if you have a white light lamp facing directly towards a driver, especially if it's at driver height, then you can imagine that's not very good for usability on the road. Even when the lamps are mounted higher and during nighttime hours, it can cause a lot of glare through the windscreen, so can't necessarily be used for environments where vehicles are going to be traveling fast. Though I would add that this is quite region dependent as well. So for example, if you go to Dubai and you drive through any of the hotels there, they will happily have flashing or pulsed white light illuminators. And partly, I guess, given due to a necessity with the plates there, but that is considered to be absolutely fine and nothing to complain about. So I think there's regional and cultural acceptance over over the use of white light. Next from Raytec is infrared, and specifically our standardized wavelength of 850 nanometers. So this provides high quality monochrome images, best for nighttime use. It's covert, so while you can see a faint red glow from the lamp source itself, it's not really actually outputting enough light for that to be construed as a warning signal or such. And because it's outside of the visible spectrum, zero light pollution and can be considered semi-covert. We also offer 940 nanometers, which is full covert, so that in theory that is completely outside of the human spectrum for visibility. So often it's called black light as an example. The downside of this is that cameras simply aren't as perceptive to that wavelength of light, so we will commonly see at least a 50% drop off in distances, and that's exacerbated if you're using a higher shutter speed on your camera, for example, which further reduces the amount of light that's hitting your camera sensor. Lastly, we also offer 730 nanometers, and that's a more recent, well, I say more recent, maybe over the last few years, offering from Raytec. Again, I've got some images that we can look at in a second, but the main benefit there is for looking through car windscreens. However, 730 nanometers is very much more within the visible spectrum. The lamp itself looks like a red light pretty much, and so it can only be used for environments or circumstances where that could be allowed. So for example, on a road, probably like a motorway road, it's probably not going to be allowed because it could be construed as a warning or a stoplight. However, for entry stations or toll stations, toll roads, that kind of thing, where vehicles are coming to a stop anyway or slow moving, then that could prove to be very beneficial if you're looking to see inside of the vehicles. We then offer hybrid units, which are a combination of both, well, usually a combination of both infrared and white light built into a single panel. However, Raytec, well, we at Raytec often like to do specials for customers, and we've often done varying different wavelengths depending on what's required, red, green, which we'll have a quick look at later as well. So just to kind of expand on that a little bit, so while infrared, I'd say, is probably the most common choice, there's scenarios where white light is essential, and this is particularly true for plates with colored characters, as mentioned with the red lettering on a white background, where infrared wouldn't provide enough contrast for the camera to pick it up. This is where white light is a definitive requirement. And the image here is from a case study that we recently put out of a project in Belgium, where these were pulsed white light illuminators. It was close range, and but the power was necessary in order to pick up the plates properly and provide high accuracy. The other benefit as well for white light is that it can give you more information. So perhaps in some circumstances, and certainly if you're driving up and down the motorway in the UK, you will notice in the average speed check zones, you've got the gantries above you which have infrared on them, but you've also got off-axis white light, which realistically you would only notice if you look to your left and you stare into the white light. I would recommend not doing that. I keep on doing it myself. I think, oh, look, there's Raytec lights. I look into them and I'm blinded for 5 seconds. But the benefit there is that you can get make, model, and color of the car as well. So they're using the infrared and the cameras on the gantries in order to get your number plate, and then they use the off-axis white light in order to get all the other detail. And essentially in that regard, if you are caught speeding, they've got you bang to rights. The next solution is pulse lighting. So as previously mentioned, pulse is a great solution for plates that are hard to read. So whether that be a non-retroreflective plate, or if that is red lettering on a white background, for example, maybe it might be also to cut through headlight glare. Pulsed illuminators deliver short and powerful bursts of light timed with the camera's shutter speed, the aim of which is to maximize performance while reducing power consumption, with the added benefit of extending the product life, essentially because the lights aren't on 100% of the time, they're only on for a fraction of the time. The LED lifespan is considerably improved. We find that if vehicles are coming to a stop, then perhaps the additional output isn't necessary. However, for entry roads or areas where cars are traveling at higher speeds, or if you are trying to get additional information, such as looking inside of vehicles, that kind of thing, then Pulse satisfies that higher power requirement in an efficient way to do so. Regarding our pulsed offerings, so we've got a good range of products, anything from our smallest units, which provide 220 watts of output, all the way up to our VTR6 models, which provide 4.5 kilowatts of output, which are considerably more powerful than any steady state product that you can get on the market in general. Now, for these types of applications, 4.5 kilowatts might be considered overkill, but actually for toll stations, and specifically we've got a very close customer in North America who is using a lot of the VTR products in order to see inside of vehicles, as I say, for toll stations, and I believe also for high occupancy lanes as well, so that they can count people who are in the cars. In the same sense or for the same reason that Watchtower decided to use our network illuminators, we also have IP/network enabled products. The main benefit for these is that you can remotely configure them, so you can fine tune light levels. Perhaps you are getting a little bit too much light and it's causing some overexposure, you can just tweak it downwards. If you are using the lights only at nighttime, you can adjust photocell sensitivity so that you can ensure that the lamps are coming on exactly when and where you need them to be coming on. Or importantly, especially for applications where lamps are going to be very tricky to access. So again, on a gantry over the overhanging a fast-moving road, for example, you can remotely access diagnostics and the status of the light. So IP lamps are definitely something that can be another arrow to your bow, string to your bow. That would be a better analogy. Lighting for signaling. So in some regions, as mentioned, we've done kind of specialist products with different wavelengths. So in this case, we had a customer in the Middle East where they wanted to use our IP network lights as basically an entry system. So they used red and green IP controlled lights that were controlled on the edge via their cameras. So when the plates were red, the lights would give them a confirmation that they can go through, which reduced the confusion that apparently some of their vehicles or some of the drivers were finding. But I think the main point here is that we as a business, we love working with customers and we love making sure that our offering is exactly what's required for any given application. And if something is needed that's not necessarily included on our base portfolio, we're happy to work with customers to see if we can develop something specifically for them that will achieve their requirements. And testing. Testing is super important. Well, essentially. We encourage all customers to test units. I think it's the best way forward. And we offer a range of agreements on trial units, demo loans, etc. We always want to make sure that, again, before a customer submits their proposal or goes through with suggested products, that they know for certain that it's going to give them exactly what they need on the end at the end result. And we at Raytech also do a lot of this testing as well. So this is an application more recently, just earlier this year, where Vaxtor approached us to help out with some long-range testing on with their analytics alongside the widely used Hanwha camera, and we were able to get ranges of up to 200 meters, up to 70 miles an hour using this particular setup with the Varia 2 i16, which is a 100-watt illuminator. So other considerations, seeing through windscreens. Now, as ANPR evolves, as barrier access evolves, there's a growing demand to see beyond the number plate and into the vehicle. Whether it's identifying the driver or checking for passengers for high occupancy toll roads. This requires different lighting strategies, often with multi-wavelength or white light and careful positioning to avoid reflection on the glass. Finding a working recipe is hard to achieve, and often we find that those who have got it working don't often like to share. But again, this is where we would highly suggest doing some testing with your specific setup. To give you kind of an idea of what we've been looking at, so we've used different wavelengths to see how what impact it has on seeing through the car windscreens. So top left there, you can see 850 nanometers, which is a very good image. You're capturing the plate perfectly well. You can see inside of the car itself, but it's not the clearest image that we've got. Covert infrared on the top right there, 940 nanometers. As mentioned, this leads to a dramatic decrease in performance of the camera due to the perception or the lack of perception for that wavelength of light. White light actually is quite interesting, so that does do a good job. But again, as we'd previously mentioned, that's also going to be providing a lot of glare to the driver, so wouldn't necessarily be useful, especially if that car is going to be moving as opposed to just standing still. And then the bottom left there, as you can see, 730 nanometers, you've got a lot lighter image, or objectively a lighter image. And you can see John Patterson there, who's joining us at the end of the call, sitting there, and you can see him a lot more clearly. This is actually more apparent when you start to take into account seeing through tinted windscreens. So again, you can see 730 or 850 nanometers in the top left there. While it was very good for looking through the front windscreen, which of course is generally always going to be transparent. When you look through the tinted rear windows, only the 730 nanometers was able to penetrate through the smoky glass, the dark window. So if you're perhaps then it becomes a case of, depending on what you're looking at, if you're just trying to see the driver. So for example, there's more recent cases of checking for people using phones and stuff like that on UK roads, then maybe you don't need 730 nanometers, but certainly if you're looking through the side windows, potentially darkened glass, then 730 nanometers becomes very well, an attractive solution. Artificial intelligence, or probably better described, machine learning, something else that's becoming more popular or common in ANPR applications. And certainly I'm working with a customer in the UK that's using it to great effect for a mobile ANPR solution. It can be used to help accuracy on dirty, damaged, or foreign plates, for example. But what we have found is that good lighting enhances the input data, of course, enabling the machine learning to perform better. As we've kind of previously mentioned, even with the best software or the best algorithm, if you've got a blurry image, then it's not going to work appropriately and not going to give you the best results. Cloud-based ANPR systems, again, something that's on the rise, offering remote updates, monitoring, easier scalability. However, high bandwidth demands make image size important, and in order to combat this, a lot of the camera operators have compression algorithms. Now, the problem is if you've got an image that's relying, and we see this very commonly, if it's relying on general area lighting, then there'll be a degree of noise in scene. The compression algorithms see that noise as movement, and so the compression isn't as effective at doing its job in reducing the memory requirement or bandwidth requirement for storing and transporting those images. So it's a sales point that we don't necessarily stress on a huge amount, but actually having good lighting can also lead to efficiencies, both from the image side itself, but also the systems behind the camera and the processing of those images. We're also seeing more focus on full vehicle analytics. So as mentioned, make, model, occupancy, tire types. This tire types in particular was a project where we were working on in Norway, looking at making sure people had their winter tires on. All of that stuff is becoming much more prevalent, but this again requires better cameras, better lighting, especially inside vehicles, as you've seen from those previous images. We've tested multi-wavelength systems in supporting this move with products designed to illuminate the interiors without glare, so i.e. the 730 nanometers. But for analytics to work, much like the machine learning, it's super important to make sure that you've got a good image with good lighting. Best practices, and to summarize this to some extent, use the right light for the right distance, clean and maintain your system regularly. So this is probably aimed at the cameras themselves, because the lights, albeit they could do with the wash now and again, they're largely maintenance free. Position lights and cameras for minimal reflection. So we kind of touched on this. So 25 to 35 degrees angle from retroreflective plates doesn't matter as much for non-retroreflective plates, though it has to be considered the effect on your analytics in order to identify characters. We also briefly touched on the ability to move your lighting away from your camera, but with the caveat that it needs to be on the same axis in order for the light to bounce off a plate and back into your camera. This can also actually be used to potentially use less lighting as well, because the light itself is actually traveling less distance if you have the lighting closer to the vehicle plate as opposed to mounted with your camera, for example. Use pulse or white light where appropriate, and this is kind of a point where it is apparent depending on the country or location that you reside or are installing in, and always test in the real world. And this is kind of like one of the key takeaways for us is testing is incredibly important. But ultimately, we want to be here to guide you through all of that, whether it be through assistance with specification, demos, and support as well. So to quickly wrap up, ANPR transforming access control, but lighting is ultimately what makes it work. Infrared is the standard, but white light and pulse can be vital in the right context. We've seen a lot of new technologies over the previous, I'd say 4 or 5 years or so, cloud systems, in-vehicle analytics, looking at different parts of the vehicle, but all of these mean lighting is so much more important than ever. And if you take one thing away from today, it's test your lights thoroughly as well as your cameras, or alongside your cameras. And with that, I invite any questions, and I will also invite John to answer some of the questions as well. So first question, how will performance be in different weather conditions such as rain or, sorry, I read that incorrectly, such as especially rainy time? Rain is always going to impact your images. Water actually absorbs infrared light. Again, it becomes a question of having the correct amount of light in order to account for all weather conditions. You can't just rely on it being good weather at all times. Of course, depending on where you are in the world, perhaps actually you can rely on that. There are lots of number plates in the UK now which block cameras. They have a grey look sheen to them and are becoming more popular. How does this hardware deal with that, or is it not able to? So I don't personally know about these particular plates. However, in my mind, they would operate very similarly to a non-retro plate, non-retroreflective. And in which case we work and operate in various regions around the world where non-retro plates are entirely are the norm, some of which are incredibly hard to capture, like Singapore plates, which are black and white, if I remember correctly. Again, it's a case of having the correct amount of light, usually a higher amount of light, and also angling, and you should still be able to capture them sufficiently. You're welcome to join in as well, John, if there's anything that you'd wish to add.
I think on that last question, you're referring to what's sort of commonly known as ghost plates, where it is actually a big issue and it is something that is being addressed by the police. So it's basically, it's the way fines and things are organised in the UK. It's actually a lesser punishment if you get caught with false number plates or ones that sort of hide the car's identity than the actual speeding offence or whatever offence has been done. And I believe it is an issue that is being addressed by the police, so that will become hopefully not so worth the risk of going down that route.
Okay, so it's more of a judiciary deterrent rather than
it is,
yeah, interesting. What is the difference between normal white light and Raytec white light? White light is visible light. There's different color temperatures. We use color temperatures that we've perceive as have good color rendition index. So pick out the colors on anything that you're looking at correctly and give you the most detail.
I mean, it's also, probably all light or visible light is very similar, but what Raytex adds is we can control that light. So instead of just flooding a whole area with a lot of light, where a lot of it's wasted, using our diffuser system and sort of carefully choosing optics and the power of the light, we can target that light so it's only, that visible light is only targeted where it's needed. So it's beneficial for light pollution, and it's also really not wasting energy either.
Thanks, John. Question, how do I demo in Karachi, Pakistan? So get in touch with Raytec directly. You can either get in touch with just the sales email address, which you can find on our website. In fact, that's what I would recommend, or via the online chat. You'll be put through to the business development manager for that region. They can assist you with getting demonstration products in hand to carry out testing. Next question, how do you compensate for hard sun shadows, cutting plate with part over illuminated? And I actually will defer to you, John, for this, but I imagine just the fact that having an additional light source directly in line with your camera, so on the same axis, will remove the issue of sun shadows.
Yeah, I mean,
that your understanding?
That's right. So again, for using retro reflective number plates, any light that's sort of directed onto that number plate will be reflected straight back at the camera. Obviously, the sun has a lot more sort of infrared than what Raytec can provide, but it is coming from all different angles, so it doesn't rely on that retro reflective property of the number plates. And also we can fit sort of narrow pass band filters, so we would just be looking at sort of typically that 850 nanometer and be filtering off any other wavelengths. So the combination of the sort of the retro reflective number plates and carefully choosing filters will reduce that sort of effect of the sun massively.
Thanks, John. Possibly dust and rainwater standing on the infrared lamp surface will impact its performance. Any automated method to clean such obstacles remotely instead of doing it manually? I think actually this is probably just not as much of an issue as you might expect, and that's partly due to the installation. So you're never going to have the lamp facing up towards the sky, where it's going to get a lot more, or more commonly, it's not going to be facing towards the sky, where it's going to be subject to the conditions as much. You're going to have it facing downwards more commonly, and in which case standing water on a surface isn't probably going to be much of an issue. Dust, I guess, actually probably would be more of an issue, but depending on the environment. So if you're in somewhere out in the desert, yeah, perhaps the maintenance requirements are more common, but certainly if you're somewhere like the UK, then you very rarely will need to go out and clean the lamps themselves. Next question. So pulse illuminators, which device has to trigger the pulse connection between camera and the spot? And yeah, this is something I didn't touch on, I should have done. So our pulse illuminators are only compatible with certain camera types. So more often than not, ANPR specific or machine vision type cameras, which have a TTL IO, and then the camera would trigger the lamp to pulse in line with the shutter speed. I think that's probably the layman's terms. Is there anything to add there as well, John?
I mean, generally it is the camera that sort of does the synchronization, so it will provide the signal to say when the light turns on. Some of our product does have a facility to provide a pulsed output, which could possibly be used to trigger the camera shutter, but generally it's the camera that does the sort of driving and the triggering and the timing of when the light comes on.
Thanks, John. The last one here, I think, is do you have a SW tool for illumination calculation? I guess that's SolidWorks. If so, yes, we have 3D files for all of our products, but we also have LDT files, so light and design tool files for the products which have the photometrics on, and we can supply those, or we can actually use we've got various different softwares to do lighting calculations on our side as well. So yep, we can supply them, but we can also assist with lighting designs as and when required. And again, we would just urge you to get in touch with Raytec directly to arrange that.
I mean, the one thing I would add to that is sort of quite recently over the last year or so, we've sort of spent a lot of time and bought some equipment which we can actually create LDT files for infrared devices, which I think we're probably one of the only companies that can do that. So we can do simulations in white light and also infrared as well. So that's probably quite unique to Raytec, I believe.
Yeah, the machine I always forget the name of, Photo.
Gonyo photometer.
Thank you, John.
Which is Gonyo for short, is it?
Yeah. I think that's the last one. So with that, I will say thank you to all who attended, and really appreciate you spending the time with us. If there are any other questions, obviously feel free to get in touch via the email address that you can see on screen there, or the phone number, or our online chat. We'd be happy to discuss any specification requirements, testing requirements, etc. And hopefully hear from you soon. Thank you very much, and good afternoon or have a good day. Bye-bye.